Hello and welcome back. Let's just go through more examples of hypothesis testing. We'll have one more section after this of more hypothesis testing as well. So here we've got a random sample of 106 people, and their mean body temperature was 98.2 degrees Fahrenheit, and the standard deviation of their body temperature was 0.62 degrees Fahrenheit. So we want to test the claim that the mean human body temperature is 98.6, which is what sort of the common thing to say is. So let's test this. One thing we should first notice that this is a random sample. Okay, so that's one criterion down. The next criterion is that either the mean body temperature must come from a normally distributed population, or we have at least 30 people in the sample. So we have at least 30 people, so we are good to go. Another thing is that in this example, they don't tell us what the significance level is. So just as a rule of thumb, I'm going to use alpha is equal to 0.05. We could use a smaller alpha, and we can compare at the end to see to what level of significance we can say. We want to test the claim that the mean human body temperature is equal to 98.6. So the claim is just that. The mean human body temperature is 98.6 degrees Fahrenheit. So symbolically, the mean, we normally use mu, and we want to say that the mu is going to be equal to 98.6. We need our null and alternative hypotheses. So the null hypothesis, H naught, is going to be the hypothesis with the equality in there, and the alternative hypothesis is going to be the one without equality. And this one, we are just testing whether or not mu is going to be equal to 98.6. So the alternative hypothesis here is going to be that mu is just simply not equal to 98.6. And that's it. So our significance level, we said that we were going to use 0.05, but at the end we'll also compare to a couple other significance levels as well. Our test statistic is going to be t, since we don't know the population standard deviation. We only know our sample standard deviation. T is going to be the difference between our statistic and the parameter that we are testing, divided by sample standard deviation, divided by square root of n. So here we have our sample mean was 98.2. The population mean that we are testing is 98.6. Our sample standard deviation was 0.62, I believe. 0.62. And the number of people in the sample was 106. So when we plug all these guys in, we get negative 6.64 rounded to 2 decimal places. Remember that for the t statistic, we also need, for the t distribution, we also need the degrees of freedom, which is 1 less than n. So now we need our p-value, and for this guy, we've got our t distribution, which looks roughly normal, and in fact, since the number of people in our sample is quite high, this is going to be very normal. The more people, the more normal it will look. And our null hypothesis here is that mu is in fact just not equal to 98.6. So we're not testing if it's less than 98.6 or greater than 98.6. So this is going to be a two-tailed distribution. So we come down here to negative 6.64, so here's 0. We are going to look for the area of this tail, but since this is a two-tailed distribution, up here, when I reflect this over, I want the area of all of the red. So both to the left of negative 6.64 and to the right of 6.64. However, the easiest way to do this is to simply take this area and take it times 2, because everything is symmetrical. So if we want to know the area of both of them, we can just find the area of one and take it times 2. So let's come over to StatCrunch. We still have the stats up from the last video. And we can come to calculators and down to the t-distribution calculator. What I'll do is I'll look at the area to the left of negative 6.64, and our degree of freedom is going to be, degrees of freedom is going to be 105. This is going to be very, very small. So 7.1 times 10 to the negative 10th power. Well, that means it's going to be 0.0 followed by 9 zeros and a 7. And that is so small, it is going to be a little bit ridiculous. So our p-value, which is going to be, what was it, 7 times 10 to the negative 10th power, is essentially 0. It's a little bit bigger than 0. And in fact, this is slightly incorrect, because what I have to do is I have to take this number and take it times 2 to find the p-value. Well, this number is so close to 0 that even if we take it times 2, it's still really close to 0. So our p-value is still very, very close to 0. So will we reject our hypothesis? Well, our p-value, which is essentially 0, only a little bit bigger than 0, is in fact less than alpha. So our alpha is 0.05. And notice that we could have chosen a smaller p-value. We could have chosen the smaller alpha. Meaning we could have chosen a higher level of significance here, and our results would still be true. So this means that we reject the null hypothesis, and our conclusion is that there is, in fact, sufficient evidence to reject the claim that the mean human body temperature is 98.6 degrees Fahrenheit. So when we reject H naught, we can come up here and we look at H naught, which is the fact that the mean is equal to 98.6. So if we can reject that, that was what our claim was. So we can reject our claim. Coming over to StatCrunch, we can also enter all this information into a nice calculator here. We can look at t-stats. Our sample, we only have one sample. This is not two samples, so we only have one sample. But this time we don't have each individual data value. We don't know each person's body temperature. We only have the summary information. We only have the means and the standard deviations. So we can do this with summary. So our sample mean was 98.2. The sample standard deviation was 0.62, and our sample size was 106. The hypotheses were that the mean was equal to 98.6, and our alternative hypothesis was that the mean is not equal to 98.6. So again, we're not constructing a confidence interval, we're just constructing a hypothesis test. So we've entered all of our information, and just for fun, I will plot the p-value as well. So this is not necessary, this is just to show this in a graph. So if we compute this, we can see all of our values. So again, our sample mean, which we told it was 98.2. We had 105 degrees of freedom. Our test statistic was negative 6.64, rounded to 2 decimal places. And our p-value was really small. It was less than 0.0001. And in fact, you could put another 4 zeros there, and it'll still be less than that. So we get to reject our null hypothesis. And when we look at our distribution, we can see that the test statistic was so small, it's almost off the sides, meaning that our p-value is also really small.